Question 7, based on previous research, the standard deviation of the distribution of the age at which children begin to walk is estimated to be 1.5 months. A random sample of children will be selected, and the age at which each child begins to walk will be recorded. A 99% confidence interval for the average age at which the children begin to walk will be constructed using the data obtained from the sample of children. Of the following, which is the smallest sample size that would result in a margin of error of 0.1 month or less for the confidence interval? So remember margin of error, when you do a confidence interval for, looks like this is mean. So when you do a confidence interval, it's your point estimate plus or minus your critical value. In this case, if it's means, t star times your standard error, which is your standard deviation over square root of n. And this part right here, that's your margin of error. That's what we're focused on here. So I want you to think about this. We're really lacking some information here. The only thing we really know is a standard deviation. We know our standard deviation is 1.5. So I want this to be less than or equal 0.1 month or less for the confidence interval. I want my margin of error to be less than or equal to 0.1. So I want t star multiplied by s over the square root of n to be less than or equal to 0.1. And this question's saying, what's going to be the smallest sample size that's going to give me a margin of error less than or equal to 0.1? So you have to test it out. You don't need to solve this by hand. In fact, I would encourage you to do the following. On this problem here, let's first go and get our t, inverse t for 4. We want this to be what percent? 99%. Let me circle that here. This is a 99% confidence interval. So we're gonna use 0.99. Make sure we divide that by 2. And your degree of freedom is always 1 less. Now these are very large numbers. So even if you put 399, that's still a pretty large number. That's approaching a z-score. That's 2.588. Now, if I do that, remember your standard deviation is 1.5. So if I take 2.588, let me pull that up again, and I multiply that by 1.5 divided by the square root of, in this case, it's 400. That gives me a margin of error of about 19.4%. That's way too big. We want this to be 10% or less. So we could go through that process again and get that, kind of keep going up in numbers. So I'm going to go to inverse t one more time. I'm going to change the degree of freedom to 899. Then I'm going to take that and multiply by 1.5 divided by the square root of 900. Okay, much closer, 12.9%, but it's still too much. So we'll do 1300 again. Second bars, inverse t. So that'll be 1299. It's always 1 less. Multiply that by 1.5 divided by the square root of, was it 1300. And we're pretty close to 10%, but it says 0.1 or less. So that's not going to cut it. So we're going to need to use 1600. Second vars, inverse t. So we'll do 1599. We'll multiply that by 1.5 divided by the square root of 1600. And now we're just under 0.1. So 1600, according to this set of answers, is going to be the number that's the smallest of those sample sizes. You could plug in 2100 and it'll give you lower than 0.01, but that's going to be the one that works.
Mr. Fowler, if you're in the building.
I also wanted to show you on the table, notice that the highest sample size is 1,000, everything under that is infinity. So when you get to a really large sample, you can approximate that to be close to normal. And also it says, based off previous research, the standard deviation of the distribution of age at which children begin to walk is estimated to be 1.5 months. We actually know the standard deviation. So when you know it, you don't need to use t. You can use the normal curve. Either way, if we would have used 99% of the normal curve, 2.576, if we had did that as our z star, 2.576, that's right here at the infinity and 99, and multiply that by 1.5 divided by the square root of 1600. You still get just under 1%. So that's effectively the same problem. So either way, D is going to be your answer. And there it is summarized for you.